Hi, so this is the list of homework. I'm not sure, it depends on how long the video is. I don't want to make too long videos. I try to limit myself to 20 minutes. So depending on how much homework we get through, we will do that. So I'm just going to look and see if there's any questions that you do need to learn or if it's relevant. So we know, why did Rutherford's atomic model require modification? Because the electron would lose, according to Rutherford's model, the electron would, an accelerating charged particle loses energy constantly, and therefore an electron encircle around a nucleus would be an example of a charged accelerating particle, and therefore would constantly lose energy and fall into the nucleus, which we know that does not happen, so it required modification. I think that's all we need to know from this part, so we will look and see. Okay, so practice problems on page 136 is the first thing that we're doing. So what are the allowed values for L? We know the allowed values for L range from 0 to n minus 1, so the allowed values would be 0, 1, 2, 3, 4, and in this case it would just be 0. And 1 minus 1 is 0, so that's the only value. What are the allowed values for ml for an electron with the quantum number L equals 0? So we know that goes from -4, -3, -2, -1, 0, 1, 2, 3, 4. And for this one, it's just 0. What are the names, ml values, and total number of orbitals described by the following quantum numbers? So this is a 2s orbital. So ml values would be 0, so total number of orbitals is just 1 orbital. 3 would be a 4f orbital. The ml values range from -3, -2, -1, 0, 1, 2, 3. So there are 7 orbitals described by those quantum numbers, 7 different orientations of that orbital. Determine n for an electron, the 2p, so 2. L is 1 for a p orbital. This ranges from -1 to 0 to 1. Which of the following are allowable sets? So n equals 4, L equals 4, right then and there you can say that's a no. L has to range, L cannot be equal to n. So that's your reasoning there. N equals 3, that's a 3p1. 3d. 1, and that's allowed. So this is fine. Part B is fine. 2, 0, so this is a 2s, and ml is 0, that's okay. 5, f, but -4 is not allowed, because ml ranges from -3, -2, -1, so that's not allowed. So that was fairly easy kinds of questions. Standard, there'll be easy marks, multiple choice, hopefully. First 3 quantum numbers. You should know how to do this question. I did list the first 3 quantum numbers, give their symbols, and identify the property of the orbitals that each describes. So first 3 quantum numbers. First is the principal quantum number. It gives the size or energy of the orbital. Second number is the secondary quantum number, is L. This gives the shape of the orbital. And the magnetic quantum number gives the orientation of the orbital. So you should know that. Identify any values that are incorrect. So 1p. Okay, so there's the problem right here. You cannot have a 1p orbital because n equals 1 means L cannot equal 1. So that's an incorrect right there. This has to equal 0. This should be a 1s orbital. I'm not asking you to correct it, just say that that's wrong. L equals 3 is a 4f orbital. So that's a mistake right there. 3p, -2 can't be a number. This has to be -1. So 4p means n equals 4, L equals 1. Again, you just have to remember S is 0, P is 1, D is 2, F is 3. There's no, I mean, technically G, H, I, J, K keeps going on 4, 5, 6, 7, whatever, but we're not going to talk about those. We stop at F, really. Here we have a 2p orbital. Here we have a 3d orbital. Here we have a 2. There, those are the numbers that fill in for a 2s orbital. Again, the n is just the number here. L is the number corresponding to the letter. ML depends on what letter you write. So hopefully those were fairly easy as well. We didn't really talk about periodic trends. This was mostly in... Oh, we did talk about... Oh, I don't want to draw complete orbital diagrams for all of those atoms. I'm not doing that. But we'll do one and then we'll just add on to that. So sodium, electronic configurations for sodium. So let's write sodium. 1s2, 2s2, 2p6, 3s1. So sodium would look like 1s2, 2s2, 2p6, 3s1. So then magnesium would be 3s2, aluminum would be 3p1, silicon would be 3p2. Note that I put the second one over here and not doubling up. I'm not doubling up on this one. I am putting a new one according to Hund's rule. So that's silicon. Phosphorus would be 3p3, sulfur 3p4, chlorine 3p5, argon 3p6, and those would be, I mean, you could draw all of them. But you get the idea. That's what you just, for each one, you just add one more electron in the proper orientation. Condensed electronic format, you know that all of this is neon. So for sodium, it would be neon 3s1. For magnesium, it would be neon 3s2. Aluminum, neon 3s2, 3p1. Neon 3s2, 3p2, 3p3, 3p4, 3p5, 3p6. Or just argon, really. You could just say argon. I don't really care. But that's that. Those are the condensed electronic configurations. So hopefully we're good with drawing electronic configurations. We'll practice this on Monday. If you still have any questions, let me or Miss McKenzie know, and we'll go through a couple of examples again, as a class or individually, however you need. Okay, so now these are probably like D block questions. Okay, so without looking at a periodic table, identify the group number, period number, and block of an atom that has the following. So we know this is a 3s1, so it has a, I forget, group 1 because it's a 1 electron, period 3 s block. Here we have a 2s2, so it's a group 2, period 2 s block. Here we have a group 5, period 5 p block. So again, the group comes from this because it goes from 1 to 18. So I shouldn't say group 5, rather. That was my mistake. It's not a group 5. This is actually a group 17. There we go. Because if you look at a periodic table, the P5 corresponds to group 17. Those are your columns. Period corresponds to your rows, and that gives you, well, if it ended in a 3D, you would know that's period 4 technically, because the D's are n-1, the F's are at n-2. You kind of have to look at that stuff, but this corresponds to the period, and then P block is basically where you're, that's kind of obvious. It's a P ending, so it's a P block. Okay, group 2 element in period 4. That's interesting. I don't even know. How do we label period 4? Oh, okay, never mind, I get it. Period 4 is the 4th period. So here you have, first one's hydrogen, second one's lithium, sodium, this is potassium, and group 2A. So here we have calcium. So, okay, so you don't really have to know that, but what we do have to know is how to write electronic configurations for these things. So period 4 means you start with a 4, And then group 2 means that's an S2, because we know group 2 belongs to the S block, so this is the ending of it, so we can basically say argon 4s2. Or, I mean, complete electronic configurations would be, 1s2, 2s2, 2p6, 3s2, 3p6, then 4s2. Noble gas in period 6. Oh dear, that's going to take a while to write the complete one, but you would say 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2. I think next comes 4f14. Does it? No, I don't think so. Is there? No, that's too high. This is a 5, so I have to do 4f14 doesn't come here. 5s2, then I do 4d10, 5p6, a noble gas in period 6. So this is still in period 5, so I still have to continue by doing 6s2, 4f14, 5d10, 6p6. That is the complete electronic configuration of a noble gas in period 6. I won't ask you to do that on a test. Obviously, and you'll have access to your periodic table, so that's not much of a challenge, realistically. Group 12 in period 4. Again, period 4 means it's some 4s. We will be careful, though, for a group 12 that looks like the last transition metal. So I would say 3d10 would be my last one, because that would be the last transition metal there. Group 16 is your oxygen group. Period 2 means that corresponds to sulfur, but if I didn't know that, that would be a 2p4, which actually I think corresponds to oxygen, not sulfur. Never mind. So that's the end. Again, you'll fill in like 1s2, 2s2, 2p4, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, then 3d10. You can fill in the blanks there, hopefully. Right, identify all possible elements that have the following valence electron configurations. So S2D1. So let's look at our... So S2D1 would be scandium, yttrium, lanthanum, and actinium. Those are your elements that have these ones. So scandium, yttrium, lanthanum, and actinium. S2P3. So an S2P3 means you can only have these, because in these the P3 comes after a D, so that wouldn't be possible. But P3 would be nitrogen and phosphorus here. S2P6, again corresponding to only the ones without transition metals, because they would have a 3d10 intervening. So S2P6 would be neon and argon. Potassium, nickel, and lead. So let's do those ones. Potassium is K. So again, I'm going to use the periodic table, and I'm going to write it using the periodic table. So I do a 1s2 first to get to helium. I do 2s2, 2p6 to get to neon. I do 3s2, 3p6 to get to argon. Okay, so we're going to write condensed. So for potassium, we basically erase all of this, and we write argon in square brackets. That gets us to up to just what I wrote, 3p6, and then we have a 4s1 for potassium. Right, nickel is over here, so it's very close to potassium, as in we're still going to start at argon. We have a 4s2 for nickel, because these two are 4s2, the potassium and the calcium, and then we go 1, 2, 3, 4, 5, 6, 7, 8, so 3d8 would be the electronic configuration for nickel. Lead, that's all the way over here. So again, back to the last noble gas is xenon. And after xenon, I know I have an S, because as soon as noble gas, I jump to here, so that would be a 6s2. I have to go down here to a 4f14. Then I come back here, continue for my 5d10s. And then after that, I have a 6s2, which gives me lead. Oh, sorry, 6p2, which gives me lead, because that's in the p block. And those are the answers for that. How much time do I take it up? 15 minutes. Let's see if we can do. We're not doing any of these guys. We're not doing this question. We're not doing that question. Identify the group number, period number, and orbital block of the periodic. Oh. So 5s2 4d1. So this is a 5th period 4d1. That means it's a 3rd group. And this is a D block. D block. Here we have a 4th period. Here that means that's a 15th group, P block. Here we have, again, I'm getting the period number from the maximum quantum number here. So this is the 5th. This is a 4D, and we know the Ds are 1 less, right? So this is technically a 5s2. So it's in the 5th period, because that corresponds to the NS, right? So it's n minus 1D. So NS means it's the 5th period. The 3rd group, so I know the S2 are the first 2 groups, then comes 10 D groups, and then comes 6 P groups, right? So 3rd group, because it's 2 plus 1 D, and that's a D block, because the electronic configuration ends in a D. Similarly here, the maximum number is 4, so that's the 4th period. 15th group, because I go 2 plus 10 plus 3 is 15, and then that's a P block. Again, 2nd period, this is the noble gas neon. So this is a 2nd period, 18th group, P block. 3s2 3p1. So this is the 3rd period, 3p1. So that would technically be the 13th group, and then P block as well. Okay. Okay, we can try question number 7. So the most common ions for the elements. So we'll practice writing ion electronic configurations. So sodium would be what's it? Argon, neon? I can't remember. I'm horribly bad at that. Neon. There we go. Whoops, there's no square brackets around the sodium. Sodium is neon 3s1. And so sodium plus electronic configuration is just neon's configuration. Calcium is very similar. We have argon 4s2. And so calcium 2 plus electronic configuration is just argon's electronic configuration. Chlorine is neon, I think. Let's check. Chlorine is neon 3s2 3p5, and so chlorine minus would just be argon's electronic configuration, because I've added an electron, so it's neon 3s2 3p6, which is argon. Sulfur, I believe, is the same. Yep, sulfur is just neon 3s2 3p4, and s2 minus would give you argon's electronic configuration. So that's the end of chapter 3. I think we're going to take a break here and continue on the next next video for the rest of the homework. All right. Cheers.